Hi everyone, my name is Nicola Corti. Today we're gonna talk a little bit about what I learned from publishing libraries for 10 years plus to Maven Central. So this talk is mostly for library authors, people that publish open source libraries, or people that want eventually to publish an open source library in their life. A bit about myself. I work at Meta as a software engineer. You can find me online everywhere as Corti Nico. Today I'm speaking about my personal experience. And I'm also an Android GD. And I maintain a bunch of libraries. If you know Detect is a static analyzer for Kotlin, I'm the core maintainer. If you know Chucker, which is a debugger for OKHTTP on device on Android, I'm also the sole maintainer. Sadly, I'm looking for people to help me, by the way. And I also maintain another library, which is called React Native, which is quite big, as you can imagine. But so that's where I started. I'm an Android engineer. That is my first library. It's called Slide to Act. I published it on GitHub, I think, more than 10 years ago. Just to give you a frame of reference, I don't have the stats anymore because Maven Central removed them. But the last time I checked, my libraries were downloaded more than 100 million times a month. So you have me here now telling you some stories about how to publish libraries. And well, so first thing first, publishing libraries, it's not rocket science. It sounds really complicated at first. You think like, oh yeah, there is a bunch of things to handle here and there, keys and signing and GPG and oh my God. There are actually a lot of really good talks and blog posts that you can go and read, and we'll tell you all the things that you need to do. I could give you today another similar talk and explain you step by step what to do, but because there are plenty already out there, I will not repeat. Instead, I will just want to focus on giving you practical tips on what is things to keep in mind when you want to publish your library. And then there is going to be like a second part of the talk, which is I will talk about some famous incidents, to call it like that. So let's start. We are here, and our mission is Mission Maven Central. We want to ship. We want to reach for the stars. And what does it mean, reach to the stars? It means getting from something that looks like this, like a Gradle command that it allows you to build a library locally, to something like this, a line that someone else can put inside their Gradle file to depend on their library. And to do this, you will need three things. First, your group, your library name, and then your versions. So in order to be able to have this nice line, it's always nice when you go on GitHub and you find a library and they just tell you like, yeah, just copy this line in your build a Gradle file and you're good to go. In order for this magic to happen, there are like a series of steps that you need to do. And this is basically our launch plan. So we start from the build. So we prepare our rocket. Then eventually we need to upload it, like send it into the sky. And before the rocket leaves the orbit of planet Earth, we have an opportunity to verify, to make sure that the rocket is ready. And then when the rocket is ready, we fully ship it and we do the release. So let's look into like each of those steps. The build. So the first thing that you need to keep in mind when you want to ship a library is that you need to have a good CI in place. When I started, my first libraries were myself compiling things locally on my machine, creating the zip, uploading that manually. A lot of things can go wrong. You should not do that. You should have good CI in place. You should have unit tests and hopefully also end-to-end tests that verify what your library are doing. Also, think about having good KDoc, like documentation for your library, because people are going to use it and they're going to read your code. And if it's not a human reading your code, maybe it's an agent reading your code. So think about having good docs, because again, it's important. If you want to go one step further, you can also set up Docker, and you will have like a nice website for your library that people can inspect. Okay, your library is ready. The next thing that you need to decide is what's your API strategy. how does your library look like for someone else that is going to use it? The easiest approach is a single library. You have one single line in a build-a-Gradle file that tell people to add, and that's so far easy peasy. But then when the library gets a little bit bigger, you might need to, like, this doesn't fit all, no? Like, there are different scenarios. Another scenario is the debug release variants. For example, Chucker, the HTTP debugger I mentioned at the beginning, follows exactly this approach. So what we tell you in the README is like, hey, in the dependencies block, add those two libraries. One for release and one for debug, because the libraries will behave differently in those two scenarios. So far, easy. But again, then your library grows even further and you need like a lot of different modules. So you might end up in a situation where you have like multiple libraries. For example, here we see this is Ktor. And this is all the sub-libraries that Ktor is managing. I mean, it has pros and cons, no? Obviously, multiple libraries means that people can depend only on a subset of the feature. They don't need to depend on everything. Yeah, it's quite long. It's also because it's a Kotlin multi-platform library, so it has a lot of artifacts. But yeah, like, you need to start thinking like, how do I want my library to look like? And then last step, this is really, generally the average user will not need these if you're a library author, but you might end up in a situation where you need a BOM, a bill of material. So for example, if you use Jetpack Compose, you probably know what is it. It's a single dependency that contains all the dependencies constraints for like a subset of other dependencies. So for example, in this case, you just depend on a BOM version, and below the users can just specify all the dependencies. They don't need to orchestrate all the various versions, because for example, for Ktor, like if like different sublibraries start to diverge, then you end up in a situation where like, okay, Ktor server 1.2, does it work with Ktor client 2.3? And you don't want your users to start getting into this mess because it's pure dependency hell. So BOM is the solution to this kind of things. Okay, so we talked about the API surface. And another thing they need to decide is your versioning strategy. Like 1.2.3, how is gonna be your library called? So the classic, most popular one is semantic versioning. People love semantic versioning because if you bump the major, it means they are breaking changes. So if you state that you want to follow that, that's great, but also stick to that. Like if you don't ship breaking changes in 1.0.1, because that's not nice. If you don't like want to commit to that, there is always the zero there. Which is just 0 dot, and then you ship whatever, you ship breaking changes in your minor. That's like really, if you want to YOLO your releases, it works. If you don't want to deal with versions at all, you can use calver, which is year.month.day. It's useful for people to understand where your library was built, but it doesn't carry any semantic information. You can go one step further. For example, forks on Node and on Linux go in the odd-even schema, which is like, hey, if the version starts with an odd, it means that is stable. And if version starts with an even number, it means that is unstable. So you know what that means. And then, like, yeah, I wanted to add another one, which is the tech versioning. Does anyone know how tech does versions? Yep. Yeah, how is it?
Add digits of pi.
Yeah, exactly. So every new tech version is a new number approximation of pi. So amazing. But yeah, just want like the mother of all tips for versioning is versions are free. You can use them. You don't need to be afraid. You don't need to be emotionally connected to your library. Oh my God, I'm never going to release 1.0, 2.0 because it's so important. No, use them. Like, try to use semantic versioning. I think it's honestly the best versioning schema you can use. So, okay. Now your library is ready, and you eventually want to start firing your rocket out in the sky. So you will need some things. The first thing is GPG signing. Again, There are guides online on how to do this. I don't want to explain step by step. I just want to give some tips on all about GPG signing. So first, what is GPG signing? GPG signing is a mechanism that makes sure that whatever you are producing, your artifacts are signed with something that certifies that you are the person that created that thing, and not someone else in this planet. So my recommendation for GPGs is create a new key only for your libraries, or ideally one key for each library, because bad things can happen. So generally, you would have in your build.gradle file a setup that looks like this, the signing plugin applied, and then you will have a signing block where you specify, hey, I want to do the signing of the release publication here. So you see there is this line, use GPG CMD. That's, I think, one of the default recommendations that Gradle gives. My suggestion instead is to use the in-memory GPG key. So the use GPG CMD will tell Gradle to effectively try to invoke the GPG command on the machine, which works if you do things locally, but doesn't really work. It's not really nice to work if you do things in the CI. So if you use the in-memory GPG instead, you can store, you should store your secrets in environment variables so that they can be used in memory. So you're passing those keys as string to Gradle, and Gradle doesn't need to invoke the GPG command, which you will have to install, and you will have to add the key inside the keyring, bunch of mess. So that's the easiest setup. Once you set it up, another thing that you need to do is distribute your public key so that people can use it to verify your library. And then, again, GPG is a pain to deal with, but it's crucial for security. A lot of other repositories don't have this mechanism, and they've been pwned. So I'm glad that Maven has it. Again, it's a bit of a pain to set up the first time, but once you do the setup, if you use the memory one, you don't need to think about it anymore, hopefully. Fingers crossed. Then GPG is the first thing. The second thing you will need is an account on Sonatype. Sonatype is the company that maintains Maven Central. So they're responsible of controlling who can publish. You will have to register your namespace. So the com.example.mylibrary. And that thing can be verified in two ways. First one is through a DNS, which is another really annoying thing to do, but basically they will ask you to create a TXT record in your DNS. Again, you do it once and you're done. Or if you don't have a domain and you want to publish under com.github.yourusername, they will ask you to verify with a GitHub project. So they will ask you, hey, create a project, call it verify, blah, blah, blah. And this will tell Sonatype that you're actually the owner of that profile. Once you do this dance with Sonatype, you get verified, and you can create an access token that you can use to publish your library. Those access tokens, you should rotate them. Because if someone steals them, they can publish on your behalf, which is, again, not nice. So what are the requirements to make sure that your release is good? I want to give you an example. This is Detect version 123 that we published last year. And yeah, this is the web page from Maven Central. They don't know what CSS is, as you can guess from that screenshot. But we can get a sense of which files we need now. So the first thing is the library itself. So the .jar of the library, or the .aar if it's an Android library. Then we need the sources file. So Maven Central wants sources included. We need a Javadoc jar, which is your documentation. It wants a POM file, which is like a manifest for the library. And then it wants the signatures. So those .asc file, they are the output of GPG. So GPG will get all of those, will sign them, and will upload them to Maven Central as well. And then the rest of the file, you see they have extension MD5, SHA-1, blah, blah. They are hashes. So they're used by the build tools to understand if the file has changed or not. You need all of those to publish to Maven Central. All the requirements are written there. They're like more, they are more requirements, like inside the POM file, there needs to be an email and the URL to the project and a bunch of things. But again, it's the setup that you do it once for one library, and then you can replicate to others if you publish several. Why I'm telling you this? Because the approach to follow here, it's first to use Maven Local. Maven Local is a great tool that allows you to verify what you're about to publish. And you can invoke it with this command, which is Gradle publish to Maven Local, and you will find it inside your home folder in the .m2 directory. And it looks like this. So, for example, this is detect 2.0 alpha 0 in my Maven Local. And I can see that the jar file are there, the sources, the Java doc are there. So before I go to Maven Central, I can get an idea of what is there, if there is something missing or not. So for the upload, gave you some tips. I think, again, probably the most important tips that I said at the beginning is all of these steps, they need to be automated. Don't attempt to sign things manually. You can, in theory, if you want, create a jar, sign it manually, zip it in. It's a huge pain. You need to try to automate. If you don't automate, doing releases for your library will be a pain. You will not do releases. You will miss users. It's going to be terrible. So spend time in automating this process because it's really important. My recommendation is to don't use the Maven Publish plugin. This is the default that comes with Gradle. You will find it in the Gradle docs. Don't use it. No good. Use other wrappers that wrap around Maven Publish. The first one is Gradle Nexus Publish plugin. And there is this other one from Nicolas Blaudi, Gradle Maven Publish plugin. You search them on GitHub. They have docs and explain you how to set it up. You set it up once, and they do the work for you. Cool. So now your release is in orbit. In the low Earth orbit. You still have an opportunity, though, to halt everything. And actually, you have two opportunities. The first one is called snapshot, and the second one is called staging. So how do they work? Snapshots. So snapshots releases are a way to stress test your publishing pipeline. So they are a mechanism that you can use to test, like all the automation that I told before. They have a couple of quirks, though. They are versioned as version-snapshot. So like 1.0.0-snapshot. They have less strict requirements. So for example, you don't need to GPG sign to publish a snapshot, but eventually you will have to GPG sign when you go to Maven Central. And the other thing is they can be republished, which is good if you're a library author because you can republish 1.0 snapshot as many times as you want. But if you are a user, and this is like a warning for all of you. If in your Gradle file you have a -snapshot in any point, that's bad. Because it's really bad because it means that today your app is building, but tomorrow morning it might not because I republished 1.0 and I changed something and I shift the breaking change. So it's good for testing, but yeah, like not really ideal to use in a production project. They're actually hosted in a different repository, which has a different URL. And yeah, like here, little fun fact for people that work in the published libraries in the past. Maven Central went through like a migration last year, which was really painful. And yeah, last year in June, they temporarily suspended the browsing of the snapshot repository where you could see like all the versions that were published and when, and it's still there. They don't have a tracker, so we don't even have a way to star the fact that this thing is broken, but it's quite annoying. I just wanted to call it out to bring awareness on these things not working on the snapshot repository. But yeah, so snapshot is one way of verifying, and then the last thing you can do before going to Maven Central is called staging. So staging is actually part of the default process when you go to Maven Central. So yeah, basically once you start uploading, it will end up in a staging repository, which is like the anti-chamber of Maven Central. A staging repository goes through 3 steps. The first one is when the repository is open. It means that it's ready to receive your files. then it gets closed. It means that the files there are valid, everything is there, and Maven Central could receive it if you want. And then it ends in the state release, which means like, okay, staging repository now has been passed over to Maven Central. So why I'm telling you this? So this terminology, you will find it around a lot in tasks that are called like close and release Sonatype staging repository, which like for people that are doing open source the first time is like, what is a staging repository? I want to go to Maven Central. Why is it called that way? It's called that way because the process under the hood goes through these 3 steps. And this is how the web UI looks like. So I'm telling you also this because in theory, you can, like what I do when I do a new library, I don't invoke close and release Sonatype staging repository. I invoke close Sonatype staging repository that will close it so that the staging repository is there. I can go and check it out. In theory, I could even point my Android app against that staging repository and consume it before I click publish. Because once you click publish, well, you're in space, like it's gone, like you can't really do anything at that point because releases are immutable, like you're not gonna change it. So if you made a mistake, you need to publish another release essentially, which, yeah, most of the time it's fine. But yeah, like timing is key. Especially when you do releases. One thing that I want to point out is that releases take hours to appear on Maven Central. Like once you do and click publish, it takes like a couple of hours. And try to synchronize your changes as much as possible. Not always easy. You will get people pinging you like, hey, the release is on Maven Central, but not on GitHub, or like the docs haven't been updated. Yeah, there is a lot of pieces to orchestrate, but yeah, timing is key when you do releases. Think twice before you click the publish button, because yeah, things can go wrong, and yeah, rockets explode. This is a nice video from SpaceX, how not to land an orbital rocket booster. You can find it on the YouTube channel, but yeah. I screwed up multiple times. So yeah, today I want to talk about some notable incidents, things that happen in the ecosystem, and yeah, like I'm just talking through them so that you appreciate the tips that I showed you before. The first one is what I call Circle CI is pwned. I don't know how many of you are using Circle CI. We were using it in 2023, and we were just back from New Year's Eve to receive this amazing Circle CI incident report for a security incident. So all the secrets got compromised, or at least they said like, consider your secrets as compromised, which is like, okay, it's like if they got stolen. You need to rotate all of them. So at this point, the tokens on Sonatype, they're kind of easy to rotate. The GPG keys are not. You need to issue a revocation certificate on your key and create a new key. It's a pain. If you have multiple libraries under the same key, all of those libraries will be invalidated. You will have to sort of, in theory, republish a version for each of those libraries. So that's why you should have one key for each library. And yeah, I mean, again, the recommendation is when you create tokens, when you create keys, always have them as scoped as possible, like only for one library, only for one account. Don't use your personal token as publishing token for, from your GitHub profile, because if that gets stolen, people will start doing whatever with your identity. Not nice. So that was an interesting one, but another interesting incident is this one, a confusing dependency. So this is the name of a blog post from Martin Brown, developer advocate at JetBrains, amazing guy. So he was building this, all days of Android also from the screenshot, Android timer, something like that, some like stopwatch. And then eventually he wanted to use this library, Android audio recorder, to record some audio. Finds the library on GitHub, and the library is on Jetpack. If you don't know, Jetpack is a repository to basically automatically publish your library from GitHub without doing all the drama that I talked to you about, which is convenient, but also comes with its own problem that we're going to see right now. So it finds the library, it adds it there in the dependencies block, and then eventually, after adding this library, just by adding the library and rebuilding, add like Gradle sync build, the app insta-crashes with permission denied, missing internet permission. Suspicious. What's going on here? So it was like, okay. It checks out the source code of the library, and eventually it finds out that this library is doing some INET address, like trying to open a socket against internet. Like, why is it like is a audio library? Like, why is it even doing that? And so what it actually is doing is goes in the repositories block and it disables this one. And at this point, this is the moment, because that library was in Jetpack, but it removes Jetpack there, and the project still compiles. So that means, where am I getting the library from? It's not from Jetpack. No, actually, I think it also cleaned the cache. So like, go check out the blog post. But basically, what happened is that someone went on Bintray and JCenter back then. Repositories don't exist anymore, and registered an account under a name which is called Jake Wharton with the double A, and was able to publish this same exact library there. So this is a type of attack, which is a supply chain attack, which is called typo squatting, where basically there is a typo in the name, and you sort of basically circumvent human checks. Because, I mean, there was a human check. Someone will have to check that account was legit, but didn't saw the double A. And, I mean, sometimes also, like, for example, Microsoft.com written like RN to look like a M. People will not notice that, and they will just think that it's legit. So, yeah, JCenter back then was less strict on repo verification. And, yeah, basically this happened. Like, they allowed malicious code to be hosted and shadow dependencies, and basically end up having malware inside your Android apps at the end of the day, which is really bad. So the takeaway here is, like, pay attention when you're using more than one public repository. Like, ideally, in your repositories block, you should have only Maven Central, Google, and other repositories which you trust and know, like not other public stuff. Because as soon as you have two public, meaning Maven Central and another public, this kind of attacks can happen. And there is a broader sort of type of attack, which is like security researchers are aware of, which is called Maven Gate, which works in this way. Again, repositories block, you have Google, Maven Central, and Jetpack. So let's suppose that me, Nicola, I have my library. It's called IO Apollo lib 1.0 and is on Maven Central. And then at some point, I burn out and I don't maintain this library anymore. Someone else will, could in theory publish io.apollo lib 1.1 in Jetpack. And now you might say, like, but hey, io.apollo is yours. Yeah, okay, it's a domain. I might not renew the domain. Someone else might register that domain, go to Jetpack, say like, hey, I own the domain, now I want to publish there. And if they publish their version 1.1, you all are gonna get a really nice dialogue in your Android Studio that tells you like, hey, this library has a new version, you want to update? And eventually you will click yes, and you will not realize that you're actually getting a different, like library from a different repository. Like there is a change of repository happening here under the hood, which is not immediately clear for the user. So having Jetpack in your repositories block also hide danger. So think about it twice. But and also, like I talked about the domain expiring. It's not only the domain; it's also your GitHub username, because you might delete your username. If you have libraries published under that username, people could register that and could republish your library and infect them. So don't delete your GitHub accounts if you have libraries, please. How you fight against these kind of things? First one, you can use GPG signature verification. So all the GPG drama I talked about before can be used by Gradle if you want with these kind of flags, right? Verification metadata, export keys. What this tells Gradle is like, hey, save all the keys that you find online for those libraries on file, and when they change, warn me. Like if those keys are changing, I want to know. Another thing that you can do in your organization, use a Maven proxy. A Maven proxy is something that you put inside your corp, and that will act as a proxy against the internet, and you can run antiviruses there. It will make your build faster because you will not have to go to the internet to re-download the packages every time. Do not let your domain expire if you have libraries there, and do not abandon your GitHub user. Really important. And again, do not use Gitpug or a combination of other public repository because that's really dangerous. And the last attack that I want to talk about today is called Shai Ulud. I don't know if you saw June. It is really interesting one. So I say here Shai Ulud, but I'm talking about like a collection of attacks that have like a similar pattern. And those attacks actually, they happen on node like NPM. So not unrelated, but just to give you an idea of the scale of those type of attacks. So those are some of the packages that got affected. I think they had like hundreds of packages. I just picked some of the most popular. Like, for example, that one, Chalk. That's 300 million download per week. And Chalk is like basically what makes your console colored. So any node tools which prints some color on console probably has that. So all of those packages, they all got compromised at some point because of some problems in the repository. So let's look at them. Well, it all started with an email to NPM maintainers from this email address. So two-factor authentication update required. This looks legit. I don't know if you ever did Node, but that's their logo, that's their font. Everything looks fine. The only thing that is suspicious is that this is from npmjs.help, which is not the official NPM domain, but I also received like emails from domain that are like at withgoogle.com, like withgoogle.com, which apparently is owned by Google. So people might think like, oh, npmjs.help, obviously is NPM. Well, it's not. This was phishing. Click on the update 2FA now. 2FA token got basically stolen. And then you have libraries like this one, really nice JavaScript libraries. They're like one function and have like 26 million download. And were published 7 years ago. And then eventually one day someone wakes up and publishes a new version. So people eventually got suspicious, and there was this one. And then eventually they realized, okay, let's look at the code. Bad stuff. This super long line which contained a lot of encrypted information, and that was like trying to basically exfiltrate all sorts of things from your machine. And again, another supply chain attack which relied on social engineering. Super common pattern. Like, there is always some human involved in all of those attacks that made a mistake at some point. But GPG would have saved NPM here. They don't have it. We have it. So let's use it, and let's not be too much annoyed when we need to set it up. Another tip that I really want to give you here is, I know when those things are happening, people are super curious, and they will really want to know, like, oh yeah, what is this library doing? What is it? What are they attempting to do? Which domain they're going to? What is this IP? In general, any investigation on this kind of stuff do more harm than good. So you basically, you might accidentally, like, open an IP address and give information about your machine, which you should have not. And a security researcher will use like a sandbox. And so if you don't know what you're doing with security and these kind of things, don't do it. I also don't do it. Like, I generally say like, hey, attack, I don't want to know, deal with that, someone look into it. But I understand is interesting. So in general, what I like to do is read the postmortems that come after the incident. It's really funny. So yeah, and with this, I hope your mission Maven Central is a success. You can find me online as Corti Nico, and I'm happy to take your questions.